Welcome everybody to the Philosophy and Technology series. The series is meant to bring together conceptual issues and technological issues around the same table. Today we have Professor Jon Agar from UCL, and the topic of the lecture will be working worlds, something that he has developed in the last few years as a methodology, I would say. You find plenty of information about Jon online. I probably have to say that he is someone who has done quite a lot of work in STS from a historical background. So when it comes to grounding his research, history is the anchor. And that's as far as my presentation goes. Jon, the floor is yours.
Thank you very much. Hello, everyone. So yeah, I am a historian of science and technology. I mean, past things I've done are things on, for example, the history of the mobile phone, the history of government's use and collection of information and trying to understand the factors that drove governments to use information in different ways, but also going the other way, what difference did it make for governments to be able to collect, process information? Did it change the capacities of government to govern, for example? And they're both sort of historical projects. But I'm also a historian of science. One of my biggest projects for the last few years has been an overview of science in the 20th century, essentially pulling together a wealth of excellent scholarship that has come out over the last few decades. But there wasn't something which pulled it together and tried to say, well, how does this look if we try and tell a story of science as it developed over the 20th century right up to now? And can you spot patterns within that? What are the main features? Now, one of my tools that I developed in that project is what I want to talk to you about today, because I think it's something that I found helped me make sense of science and technology in the 20th century, and it's something that I want to develop further, because in fact it was an idea that came fairly late. It was like I can spot a pattern of things that I've already been thinking about, writing about, and it made it into the book, but it is also something that I'm well aware could be criticised, maybe has problems, and is therefore something that I am trying to put on a firmer foundation, which is why I'm delighted to be able to talk to an audience like this today. So to get a sense of where I might be going with this, a story, an image really that I think helps is imagine yourself in an aeroplane flying at night. You know, when you take off at night, you start flying around, you look out the window, and if you're a long way from a city, what you see is something like this, right? It's a sparkling set of lights. It's quite sublime. This is London. I tried to find a picture of Oxford at night, and I couldn't find one, which I was surprised by. But this is London. But essentially, what you see is something that is difficult to make sense of. But if, say, when you're coming in at the end of your flight, you're flying into a new city, and it's dawn, what you see is not just the lights, but you see the movement. You see basically a city at work. Now, what I think, where I'm going with this, these images are that this is a kind of way of thinking about two styles of thinking about science. One is looking from a distance, and what we just see are the very bright lights. We see development of quantum mechanics there, relativity here, so the Human Genome Project at the end of the 20th century. These are sort of standalone, very bright lights, but don't make sense in terms of in themselves alone. You don't understand where they've come from, even though you might be very impressed or even in awe of them. But when you start seeing those developments as part of a world of work, a world of what I call working worlds, a bit like this when you come and see the city at dawn, where you see all the movement. You can make sense of that. People are moving around, going to work. There's traffic, and the traffic's going places. Then you begin to be able to get a handle on science in a broader context. So, what I call working worlds are something which relates to the sciences in the following way. Sciences solve the problems of working worlds and also draw inspiration from them in other words. But in particular, these working worlds are the arenas of human projects that generate problems but are not able to be solved directly. Okay. So, here is a very simplified picture, and I'm going to talk you through it, give you a sense of how I see working worlds generating the sciences, and in a particular way. So working worlds are the arenas of problems, but they generate problems. Problems, though, are something that are actively achieved. So problems have to be articulated, they have to be given a particular form, they have to be given names. And there are various strategies that we find where problems are identified. One is, for example, aggregation. Death, for example, an individual death is a tragedy. But when you start aggregating deaths, then they can become a problem. So, for example, in 19th century London, if you, as was done, aggregate the number of deaths from cholera, it becomes a problem that it calls attention for further work. Another example of aggregation, a single movement of a person is not a problem, but aggregated movement can be a problem for civil administration. I'll come back to those examples in a second. Another strategy is selection. So a characteristic of a working world can be picked out as being a particularly problematic status. Now, the examples of working worlds that I identify in the book are these ones. The construction and maintenance of technological systems is one. The care of the human body in sickness and health is another. Civil administration is a third. The mobilisation and maintenance of fighting forces is a fourth and particularly important one for 20th century science. I might add a fifth now, which is the monitoring and maintenance of global order, whether it's environmental stability or economic dynamism. But going back to here, the next stage, having articulated a problem, well, the sciences respond to working worlds in a distinctive and arguably definitional way. Because working world problems cannot be solved directly, science typically makes manageable, manipulable, abstract representatives. So simplified representations, I've called it there. Now these are simple in comparison to the complexity and intractability of the working worlds themselves. So for example, going back to 19th century London, John Snow, the physician, drew up maps of cholera deaths in the 1850s. Now, those maps put on a page the complexity of all the cholera deaths in his neighbourhood. And they are simpler than the collection of diseased bodies in the busy metropolis from which they were drawn. Going back to my second example of the movement of people, well, the census is a simplified representative of the population. It's an incredibly expensive representation. The 2001 census cost about £255 million to make. It involved thousands of staff. It took 13 years to organise the data, but it is worthwhile compared to the expense and complexity of the problems of movement and other problems, of course, that the census helps civil administrators solve. Okay. Another example of a working world problem, let's go forward, would be the mid-20th century problem of the working world of warfare was the speed and invisibility of incoming aircraft. Right? Now, the solution to that problem turned out to be complex radar systems of various kinds. Right? And the point that I want to draw your attention to is that's the sort of technological outcome, a system that helps identify and track and so on in aircraft. But they also involved the building of simplified representations. And in fact, that was absolutely key to the operation of radar systems. The airspace alone is incredibly complicated, but at every step in the operation of a radar system, information is selected, filtered, reduced, so that you could have at the crucial centres a much simplified representation of that incredibly complicated working world. So this, for example, is the filter room at RAF Bentley during the Second World War, and it's the simplified representation, the information that I'm drawing your attention to there. And of course, there is a whole science that is based on the on making sense and manipulating that representative. The sciences of what was called operational research. Okay. So it generates new sciences in the 20th century, and radar generates more new sciences than almost any other technological system. Also, crucially, it comes with the articulation of information really for the first time as we would now understand information. Okay, so this is one of my favourite pictures. It's a I don't know whether you can see it at the back, but what you're looking at is an organisational chart of the British radar system during the Second World War. So this is a chart made during the Second World War as well. And essentially you see various sort of observer centres, various radars, various radar-controlled gun laying, radar guns, and other sort of parts of the system. It's about how the data is taken through the system, but crucially this whole system is now understood in terms of information. So at the bottom we see incoming information, I don't know if you can just see it, and outgoing information. So information becomes something that is talked about in ways in which we recognise in eventually information sciences. We also have key terms being coined at this very moment too. Here's another organisational chart from the 1940s, and you can see at the top it's AA command, information system. Information system, the understanding organisations in terms of information are a product of this moment. That's a bit of a detour, but one I hope you find particularly interesting at the Oxford Internet Institute. Going back to the picture, though, I've told you about how working worlds are intractable on their own, but problems are articulated. The scientists respond by building simplified representations. And the next stage is basically the kinds of things that we would call science, right? It's all the theory building, hypothesis testing, data collection, observing, and so on, that interests philosophers of science, historians of science, and indeed scientists. Right? That alone is not the end of the process, because there has to be a reverse flow. If the first stage is problematization, the last stage is, and I hate this word, but I do tend to use it, solutionization. Solutions have to be articulated and made sense of in ways which help those who have the problems in the first place. And that, again, is not a trivial process. So John Snow, yes, with his cholera maps, famously, it's a bit of a myth, but it's more or less accurate, intervened back into his working world by going back to take off the handle of the water pump, having identified where the source of cholera was. The Office of National Statistics makes their statistical census information useful back to the users of their information. All that work is not trivial and is an essential and important part of the story. So that gives you a sense of what the concept of working worlds are, how it relates to the sciences, how it sometimes relates to the generation of new sciences. And as I said, I found this actually a recurring pattern when looking at the sciences in the 20th century. Second claim is that, in fact, it often helped understand moments that you might think of as being key episodes of pure science. I mean, obviously, I think we can see that it's going to be the kind of story you might tell about applied science, right? You know, I think when you're talking about industrial chemistry, it's no surprise that industrial chemistry is responding to the needs of or problems of producing new products with new chemicals and so on. But I think it also helps when you look at what good historians of science have written and understood of some of the key more theoretical, more pure episodes in the sciences in the 20th century. It also helps us understand those. So, for example, David Cahan's book, An Institute for an Empire, which is a fine study of the Physikalische Technische Werkstattanstalt. It's the German standards laboratory set up just over 100 years ago, but really the model for all standards laboratories in the world, including the National Physical Laboratory in Britain. In his book, you find a really fine-grained historical case study that tells us where Planck sat when he was developing the first quantum theory. Right? And I'm not going to talk about it in detail, but essentially the PTR, the Standards Laboratory, was charged with helping the German electrical industries, including the electric light industry. One thing that it wanted to do was generate much better data about luminosity. Right. So it was responding to a working world problem, which is designing better electrical systems. It was generating simplified representations, which are the data, very fine measurements of black body radiation and other things in the Standards Laboratory. And Planck was one of those who was trying to make sense of that data. And in order to make sense of that data, he proposes the equations which contain the terms which are interpreted as quanta. Right? So looking in using drawing on contextual history, which I think is the best historical accounts that we have, we do also see this kind of working world story applying. Right? So I think it certainly can help us understand things like development of quantum theory. With Peter Gallison's work who's a very good historian of physics. You may well know his work. I think we can also relate much of Einstein's special relativity work to certain concerns within the cities that he was living and what he was doing at the patent office. Turns out the standard story that Einstein's the third-class patent clerk. What a tragedy that someone like Einstein had such a post. Well, actually, it turns out it was a perfect place to look at if you wanted to see all kinds of designs of technological solutions to problems of coordination of clocks, for example, not least. Okay. Don't want to be too crude. Obviously, there's a big step between sitting at a clerk's desk and seeing patented patents for electrical coordination of clocks and developing special relativity, right? There's still a long way to go. But the point is that making sense of it, right, works when you consider those kinds of working world things. And it's not a stretch. I think you can draw it in a fairly straightforward fashion from good historical studies of science and technology. Right. So that's told you a bit about the working worlds idea and how it works in a few examples. For the remainder of the talk, and I have kind of lost track of time.
We have plenty of time.
We have plenty of time. Yeah, that was my impression too. It's probably going to be quite a short talk, so there'll be plenty of time for discussion. What I want to do is talk about some problems that I've identified with this idea, both looking backwards, making sense of the past, but also looking forwards, so making sense of today and tomorrow's science and technology. And then I'd like to hear what you think. So looking backwards to start with, one question is, how many working worlds are there? Does it matter that that they overlap, perhaps? So we take something like military medicine. Now, military medicine is both a solution to working world warfare problems, but also a problem of maintaining human health. Does it matter that one science can be springing from more than one working world? Does it matter that the definition seems fairly loose? I think probably for some people here, yes, it does, right? But I want to know whether it can be tightened up or whether it's a really serious problem. Secondly, how far back can this go? I mean, this came out of my attempt to try and pull some meaning out of understanding the sciences in the 20th century. But does it work further back? Is there a working world for alchemy? I don't know. Is it something that is is it characteristic of modern science in a certain sense? Again, I don't know. Thirdly, why don't we know this already? I said that if you read some of the I think are very good contextual histories of science, you do find this sort of picture. But it does run up against, I think, perhaps a more naive, more common sense understanding of the development of science. So how do I account for that? Well, I think certainly one of the things that does happen is a lot of those connections are written out, that they are erased. So there are reasons for telling stories that intellectual ideas spring perhaps only from other intellectual ideas, or that they have less connection with the world around than perhaps a historian might find. And I'd be happy to talk about that process. Sometimes we can see that erasure in action. So we can see accounts being built up over time of how a certain scientific development happened, and more of the context being dropped as the stories have been told. Fourthly, I've rather pretentiously called this the End Shadings Problem for historians. The End Shadings Problem is Turing's problem, right? It's the halting problem. For him, it was the really important, what he solves in the 1936 paper, where he proposes the universal Turing machine. It's one of Hilbert's foundations of mathematics problems about can you say for sure whether a mathematical process will can be completed. Right? Now, for historians, the halting problem is as follows. If you think of a historical account being a series of causal claims, right, so different sort of factors being of influence, then you start with something that you want to explain and you build a causal chain that leads to it. And if you follow that causal chain back, well, you do have a choice of when to stop. And if you stop with a social factor, you conclude that you're doing social history. If you stop with an intellectual factor, you might conclude you're doing intellectual history. Right? So there is something arbitrary in where you can stop. Right? Now, why is this important? Well, because obviously the kinds of explanation that I'm invoking for the development of the sciences is quite a large maximal one which would essentially root itself in what I call working worlds. But if you are a historian of ideas, let us say, you may choose a much shorter and maybe even finer detailed causal story to tell, one which essentially relates ideas really to surrounding immediately connecting ideas. So there's perhaps I'm not a philosopher, but I think there's something that's interesting about the philosophy of history there, which may be of interest. The fifth issue I've listed there is: do cases of insulated science exist? Now, when I published this book, it got some nice reviews, but it got some critical reviews as well, friendly critical reviews. And one of them said, well, listen, this working worlds idea is fine, but I can think of sciences which are not like that, which have developed in a more hermetically serialed way, are more insulated from working worlds. So Graham Gooday, who's a historian at Leeds, at one time was here at Oxford as well, he pointed out, well, what about black hole science? What possible working world explanation could you come up with for the generation of the physics of black holes? Right? It doesn't seem to be responding to any working world problem that he could see. Now, I have to think through whether actually that's just an anomaly or a contradiction, or it's a problem, or it's something that I can tell a working worlds account. But I'd like any other suggestions of similar cases to think about as well. And finally, I'm not going to talk about it here, but what are the similar concepts? What does this idea make you think of? Right? Because it's something that I've rather plucked out myself, and as you can see, it's fairly underdeveloped. But it might well. What is its genealogy, and what similar ideas are there in the past? Are they better? Are they worse? How do they connect? So thinking through connections with similar concepts is also something I want to explore. Okay. Looking forwards with working worlds. Well, is this an idea that helps people thinking about the sciences and technology today, science policy people, and others? Well, what sort of things might I ask people to think about? Well, one of them would be, I think that there is very little, possibly no, truly curiosity-driven research. The blue skies represent blue skies here. So it's again that language which we still hear and is jealously guarded, that there is a role and importance for curiosity-driven research. And I don't doubt that many people even think that they are doing curiosity-driven research, But I think drawn into a larger picture, they possibly are not. And I worry about that claim. Okay. Other things. I've told an account of how the sciences respond to problems, but, and this point was made to me by my father-in-law, so it's not one I could really ignore. He works in educational aid around the world, Africa, Oceania, places like that. Now, what he pointed out was, look, there are plenty of problems which are articulated to which the sciences do not respond. Right. Now, good examples of that are diseases in developing countries which are not, even though there's been lots of initiatives to try and kick-start research on them and to develop it, still do not attract the research which it might expect. So the problems that generate no science is an issue. I think is a problem really for me rather than a problem for others, perhaps. Secondly, cases where, and this is getting attacked by all sides here. This challenge came from my PhD student who said, no. Well, think about it this way. Are there such things that have all these characteristics I've been talking about? So a working world, problems being articulated, representatives being built, and work being done with those representatives, which are still nevertheless things we might not want to call science. Right? So it's that category. Are there things in that category? And I couldn't think of one, but I'd be very pleased to hear of suggestions. A couple of thoughts, though, for how this might help science policy thinking. One thought is that this might give empirical support to the strategy of offering artificial challenges. So by that I mean things like the space race. Right? Now the space race was an answer, I suppose, to a problem which was Cold War rivalries in many ways, right? But it was a challenge. It was set up as a for example, the Apollo missions to the moon. It was a big, large-scale challenge to which people were expected to race. Going to the moon in itself is not a problem for people, right? It has to be made a problem, right? And the outcome was the development of quite a lot of technologies, quite a lot of sciences of different kinds. And therefore, it may support the idea that more artificial challenges like that do have a role in driving driving the sciences in this case, and technologies too. My home university, UCL, does take this sort of approach. It's very proud of what it calls its grand challenges. Right? So it has 3 big overarching challenges that it tries to get everyone, well, not everyone, but people within the university to come together to help solve. Now these are ones that are recognisably working world things like global health, right? So they're not novelties, but setting them as challenges and asking, in this case, sciences in various different disciplines to respond is in itself artificial, I think. And again, this sort of account, this might give sort of empirical support to that sort of approach. Yeah. And lastly, it's really quite a simple point, is that one of a sort of recurring target that is sometimes set is aiming for certain levels of R&D spending. Right? So if you look at R&D spending in international comparative terms, you find numbers between 0.5% and 3% of GDP. Right? And Britain spends somewhere between 1 and 2, right? Near 2. But you sometimes have arguments that if only you just raise the level of R&D spending, lots of good consequences will follow. So targets of raising R&D spending to say 3%, right, or 2.5%. These have been in different countries actually targets that have been set. There's one for Europe as a whole, for example. Now it does seem to me that if my kind of analysis is in any way correct, then that kind of policy is putting the cart before the horse. It's essentially a style of cargo cult thinking that if you reproduce something that looks like a successful science policy innovation system, in this case levels of R&D funding, then other good consequences follow. What that's missing, of course, is the notion that the sciences follow the problems which have been articulated. All it does is set levels of funding for the sciences, which is, as I said, putting the cart before the horse. Okay, so I think that's all I want to tell you about today before discussion. I hope you found there's some interesting ideas there. And I'll turn over to discussion. Luciano, thank you.